Welcome back to the Explainer. So today we're tackling a massive hurdle in the embedded developer world. Look, you probably know the feeling. You've learned STM32 bare metal programming, right? You can easily toggle those LEDs, read basic inputs, no problem. But honestly, you still kind of feel like you're not ready for real, industry-level projects. There's a huge gap between blinking an LED and building a commercial product. Well, today, we are going to lay out the exact roadmap to completely bridge that gap. To really understand this jump to professional engineering, let me ask you a very simple question. How exactly do modern embedded products handle multiple tasks at the exact same time? Think about the devices we use every single day. They aren't just running one thing in a simple loop, patiently waiting for it to finish before starting the next thing. No way. They are incredibly dynamic.
Okay, let's dive into this with Section 1, the bare metal bottleneck.
Think about what's actually going on inside a modern device. The microcontroller is literally working overtime. It has to constantly read data from high-speed sensors, instantly update a display so the user doesn't see any lag, communicate over UART, actively handle a super complex Wi-Fi stack, and send precise signals to control motors. And here's the kicker. It has to do all of this simultaneously. Every single one of these tasks is screaming for the processor's attention right this second.
And, well, this is exactly where sticking to basic bare metal programming becomes a massive bottleneck. Managing all those simultaneous tasks using only a bare metal architecture gets incredibly difficult as your projects grow. Imagine you're in a massive super loop and there's a tiny delay in handling the Wi-Fi. Suddenly, your motor stutters or your entire display just freezes up. It's like a giant puzzle where one wrong piece breaks the whole shebang. The complexity just doesn't scale to what modern industry actually requires.
Which brings us to Section 2, the RTOS solution.
So, the crucial point here is that most professional embedded products don't rely on those massive superloops. They use an RTOS, a real-time operating system. Instead of you, the developer, trying to frantically juggle a million things perfectly in your code, an RTOS steps in like a dedicated air traffic controller for your microcontroller. It guarantees that every single task gets the exact processor time it needs, exactly when it needs it. It's an absolute game changer.
And when we talk about RTOS, there's one name you absolutely need to know: FreeRTOS. It is, without a doubt, one of the most popular RTOS solutions in the entire world. By learning FreeRTOS alongside your STM32 skills, you're getting a true behind-the-scenes look at how real commercial embedded systems are designed and developed out there in the industry.
Now, what's really interesting about this next section is getting into the actual mechanics of how this works. Section 3, FreeRTOS Core Concepts. So how do we actually master this? You need a solid, step-by-step path. First, you lock down the fundamentals. Second, you dive into those core concepts so you truly understand the underlying mechanics of the operating system. And finally, step 3 is real-time project development. You take all that theory and immediately apply it to build robust, real-world systems.
Okay, so what exactly are you learning? We're taking the black box of professional development and busting it wide open. You'll master task creation and scheduling to control exactly what runs and when. You'll use queues for seamless inter-task communication, passing data back and forth. You'll get hands-on with Semaphores and Mutexes. Think of them as digital locks protecting your shared resources from crashing into each other. Plus, we'll cover software timers for precise timing and memory management to keep everything perfectly stable. Basically, it's the complete blueprint for complex systems.
Let's move to and see how this builds your career in Section 4, becoming industry ready.
Here's a hard truth about the job market right now. As the source material points out, most students stop at bare metal programming. But companies are looking for engineers who can build scalable and professional embedded applications. There is a very clear dividing line here. Are you going to just write simple code, or are you going to step up and architect reliable, professional systems that companies actually want to hire for?
If your ultimate goal is to become a top-tier embedded systems engineer, learning FreeRTOS isn't just some optional nice-to-have. It is literally the next necessary step in your journey. Join our STM32 FreeRTOS Bootcamp, and you'll learn absolutely everything from those basic fundamentals all the way to deploying real-world projects. I'll see you inside the bootcamp.
As we wrap up today's explainer, I really want to leave you with this one provocative question. Will you stay stuck at bare metal, fighting complexity with limited tools, or are you ready to level up and build like a professional? The choice is totally yours, but the path forward is clearer than ever. Thanks so much for hanging out with us today, and we'll see you on the next explainer.